All right. I'm going to be talking about using Docker as a potential replacement for Tox. So who am I? I'm Nick Lang. I am Fixed Gear on Twitter and on GitHub. I work at Elastic, and I like to run. So what does this talk about? So I'm not going to give you like a one-size-fits-all solution, because nothing, like, Tox is still a very good tool, but it does have its kind of limitations. And so I'm going to try and give you some ideas to think about to come up with a solution of your own that fits your own specific requirements. So who here is familiar with Tox? Okay, so less than I anticipated. Tox is actually a really good tool for testing your Python code against a variety of different Python environments. So if you wanted to make sure that your code worked with Python 2.7, worked with Python 3, worked with PyPy, worked with Jython, you could actually configure your code so that, or your Tox file so that you can test all of these different versions of Python with your code base to make sure that you don't run into any issues regarding features in Python 2.7 versus Python 3. The nice thing about Tox is it's very stable. It's been around for a long time, so if you have problems with it, you can search up blogs or Stack Overflow questions to make sure that you're doing things right, or you can solve the problems that you might be having with it. And also, Tox has a single file configuration, which is really nice and easy and simple to get up and running with. That helps you come up to speed a lot faster. But with that, there are some problems. First is going to be that it is also a single file configuration, which means the more complex your environment gets, the bigger this configuration file is going to get, and it's going to be a little bit harder to manage that single file over time. Also, there is no parallel execution of your tests when you run in Tox. So what that means is, first it'll run the 2.7 unit tests, and then it will run the Python 3 tests, and then it will run the PyPy tests, and then the Jython tests. And so each time you add another element into your test matrix, it's just going to expand the length of your test run by the length of how long it takes a single environment's test to run. It's also hard to guarantee that the test environment is going to be the same when you run it locally on your machine versus running in a CI versus running on somebody else's machine. My least favorite statement in software development is it works on my machine. Also, Tox requires that every single version of Python that you're trying to test against is installed on whatever machine is running the tests. So if you're trying to test against multiple versions of Python, now you have to make sure that you have Jython installed on your computer, PyPy installed on your computer, Python 3, Python 2, and if you're doing different minor versions of Python as well, all of those have to be installed, which can be kind of a pain to manage all that. And then also, Tox does not give you a guarantee of isolation of third-party services. So this is stuff like Redis or Elasticsearch or Postgres. So if you need to make sure that your tests run against, or that your application works against multiple different backend services, Tox doesn't really give you a good, clean way to manage those third-party service dependencies. And then finally, virtual environments are not really all that portable. I know you can tar it up and zip it and compress it and move it from one place to another, but then also you still have to worry about those third-party dependencies, making sure that the right version of Python is installed wherever you uncompress that zip file. So while it is portable, it's not that easy. So Docker, is it really better? Well, arguably, yes. Your tests will run in a production-like environment wherever you are running your tests, whether they're running on your computer, running in CI, Jenkins, whatever. They're guaranteed to be run the exact same way with the same dependencies installed. Also, your tests can be run in parallel. So the bigger your test matrix gets, the faster you can run your tests. And then similarly, your test environment becomes portable. Docker images are guaranteed to run the same way on whatever computer that they run on, as long as that computer can run Docker. So you have the guarantee that your tests will always be run the same way. So obviously there's going to be some trade-offs. The first one is that there's going to be some more upfront work. The more environments that you want to test against, the more backends you want to test against, you're going to have to create essentially a Dockerfile, create a Docker image for all of these different elements in your test matrix, which could lead to many, many files. A lot of those files end up becoming the same, so we can actually take use of some templating to manage that. Also, we're going to need a little bit of more work to actually gather the test results themselves. I don't know if you've ever run something in parallel before, but you end up getting a mishmash of all of your log output at the same time, which can be kind of hard to parse. And then the last thing is system resources. The more containers you have running on your computer, obviously the more resources you're gonna need. So this can be solved by using bigger machines, using something like Kubernetes or Docker Swarm to actually scale this out horizontally across a variety of nodes. So, why are we doing this? The first is many different backend versions, and I made reference to this before, but working on the Elasticsearch client library, I've noticed that if I want to test against multiple versions of Elasticsearch using the Elasticsearch client, it can be kind of a pain to switch back and forth between Elasticsearch 5.3 and Elasticsearch 5.4 and Elasticsearch 6, and like it can be kind of frustrating to go back and forth with these backend environments. And similarly, configuring these backends. So, starting one, starting another, making sure that you're running the right version at the time when you run the tests. Like this can be frustrating and kind of a pain. And then obviously we have different Python versions. Tox is really good at handling this, but we can also kind of get that same flexibility using Docker. So that said, what does our test matrix end up looking like? Well, right now we have 16 different test environments that we need to run, but all of a sudden we add Elasticsearch 6 into the mix, and then we need to make sure that we're actually testing with Python 2.6. So all of a sudden we've just added 8 more elements to this test matrix, which if we're running this in Tox is going to be 8 times, or what is that going to be, 24 times the length of our normal unit test time, which can add up to a very significant amount of time depending on how long your tests take. So this is a kind of an example Dockerfile that I've kind of put together when experimenting with this. Are you guys kind of familiar with Docker? Yes, no, okay, oh, everybody, or most of you, that's good. So here, the from line. This is basically how we can control the Python environment we want to use. Right now, this is just using Python 3.4, and I'm using Alpine because I like how small Alpine images are. The next thing, I need to install a few tools into this image to actually make running the test actually work. Next, we're going to create a working directory called code, where I'm going to clone the Elasticsearch and the Elasticsearch client into that directory. At Elasticsearch, we make use of some tests that are in the Elasticsearch Git repository in the client library so that we don't actually have to rewrite hundreds of tests in every different client, Node, PHP, Perl, all these things. We can actually reuse some of the tests that are written in the Elasticsearch Git repo. And then next, I need to install some pip requirements to make running the test possible. And then I change my working directory, and then I'm actually going to install the Elasticsearch client using the develop, and then I'm going to add a wait for Elasticsearch shell script. So I already talked about the from. This is how we can change all of the different Pythons we want to test against. If you need to create your own base image for your specific environment, you can definitely do that, and you can just change out the from, and this can also be templated so that you only really need to manage one Dockerfile at this point, and you can iterate over all the different versions that you need to test. The wait for elastic. This is kind of an important thing. What this is going to do is this is going to actually check to make sure that Elasticsearch is healthy and ready to go before the tests actually run. This is useful if you're doing something with Postgres or Redis or whatever. You want to make sure that when the containers start, that the container running your test is not going to run before Elasticsearch is actually ready to accept connections. And so then the next thing is Docker Compose. It's a really easy way to just encapsulate all the different environments, all the different elements that need to be tested. This is not going to be something that will actually work, but I just kind of wanted to highlight a couple of the things in a compose file that you would need to run. So the first thing is we're defining a service within Compose that's called client 5.3. It's using an image that is the result of that Dockerfile that I showed you before. We're specifying a special network. We're specifying a special volume. And each of these, the network and the volume need to be special in the case that we don't want to have, say, Elasticsearch 5.3 client communicating to an Elasticsearch 5.4 instance container. So we can actually control and isolate the network communication between our client and our service so that there's no contamination across our instances. And similar with the volumes, as a result of running the test, we get some artifacts, and those artifacts need to be shared between the client and the service running, but we don't want any other clients or any other services to be able to tamper with that. So this is using a Docker volume that isolates those particular components. And then last is next is the depends on. And the depends on, all that's really going to do is it's going to make sure that the Elasticsearch container has started before we actually start the Elasticsearch client container. But we still need that waits for to make sure, because Elasticsearch has a boot up time. And then finally is the command, wait for Elasticsearch. The -- is just basically a placeholder. You could specify a specific host in there if you wanted, and then Python setup.pytest, and this will actually run the tests. And then next is an Elasticsearch image, or the Elasticsearch service itself. I'm specifying my Elasticsearch image. I then specify the network and the volume, and then the last 4 lines are actually how you name a network and name a volume within Docker Compose. And expand this out a little bit, and it becomes pretty straightforward to expand upon this. So I guess I gave you the notes on the Compose file already. We want to be able to isolate a particular element in our test matrix so that we don't have any cross-contamination between other containers running at the same time. And what this means is that our tests become really simple to run. It's just a simple Docker Compose up. This will start all the containers at the same time, it'll get everything running, and then the tests will just start running on their own. Collecting the test results, if you run Docker Compose up, you're going to just see a stream of text come down your console, which can be really hard to process and manage, especially if your test matrix gets really big. Luckily, though, the output of all of the tests are stored within the particular container. So you can actually just do a Docker logs on a container ID, and you can see the output of the test for that specific test element. So what's next? We have a way to run our tests, and we have a way to view the results of our tests, but this doesn't really help us all that much because this is still a very manual process. Running Docker Compose, looking at all the logs manually, checking the exit code. An exit code of 1 means that the test passed, and exit code of 0 means the test passed, and exit code of anything else means our tests failed for whatever reason. So the next solution is we need to automate all the things. Who here likes automation? Yeah. So we need some way to execute all of this. We listen to GitHub pull requests, webhooks. We listen to Bitbucket webhooks. Something to trigger a way to say, hey, I need to run the tests again. So this is a really simple executor function where we have our function that's listening to GitHub. It receives the webhook, and then it calls the executor, which is basically just going to be a sub-process that just calls Docker Compose up. The -D means it runs in the background, so you're not going to be streaming all that to the console. And then next, we need a way to monitor what's going on. How do we know when the tests have finished running? When do we know that things are done? This kind of stuff. So Docker provides an event stream. The Docker events command will give you a help entry into that. But what we can do is we can filter on a specific event that we're interested in, and that is the container die event. And what that means is the container stopped running. We can specify this filter, event die. This will give us some output of when the container stopped, what the event was, the exit code for that particular container, the image that the container started from, and the name of the container that had actually finished running. So here's a really simple monitor function. Basically what we're going to do is we're going to create a Docker client from the Docker. The import Docker is the Docker Python SDK. We can create a client object, and then we'll create a simple while loop that just keeps going forever. And it's going to be looking for events coming off the event stream. And anytime we get an event that is a die event, we're going to do something with that event. And next, we need a way to collect and report on what had happened with that container. Our collector is going to be something that can collect the logs, store the logs, put them somewhere that's useful, whether you want to put them into, say, Elasticsearch itself, or create a J2 or JUnit XML for reporting in Jenkins. If you just want to have it emailed somewhere, you need somewhere to put the output of that container, and also the exit code for what that container's exit was, so you know if your tests passed or failed. And then also we need the reporter. So the reporter is going to essentially say that we had passing tests or we had failing tests. And here's a really simple collect and report type functionality. Given the event, we can collect the container ID from that event. Then using the Docker client, we can actually get that container object. From that container object, we can get the logs. We can also get the exit code. I think that's supposed to be, I think I screwed up on that. But anyway, you get the idea, it's just pseudocode. And then we can actually log the exit code with that particular container ID. And then we can also store the log data with that container ID. So we can make it easy to view the report that comes out from running these containers. And then finally, we're going to need some cleanup. The bigger problem is going to be after all of these tests have run, we're going to have a bunch of containers and volumes and networks that are just lingering around. This can be, over time, this can eat up your disk space, and your tests will start failing because there's no more space to make containers. So we need a way to figure out what containers need to be cleaned up when they're done running their tests, figure out the volumes that were used, figure out the networks that were used, so we can actually remove all of those programmatically. That's pretty easy. In the example of the compose file that I demonstrated, we know that our containers are going to be in the names of elastic underscore client 54 underscore 1. So we can separate on our underscore, and then we can navigate down to just the 54 in the client, and then we can pass that version number into a cleanup for containers, a cleanup for volumes, and a cleanup for networks. Using Docker Compose, Our volume names are going to be determinable. Also, the networks, containers, and volumes will all be determinable based upon how we've set this up. So our volume is going to be elastic underscore ES53 or ES54. Our volume will be elastic underscore ES53. And then the container name running the Elasticsearch instance itself is going to be elastic underscore Elasticsearch 53 underscore 1. And we can just target all of these particular things specifically so that we remove them without actually obliterating any other tests. So these tests can actually be run and cleanup can be running at the same time without any overlapping. And it appears that I went a little fast. So if you guys have any questions, any comments. Also, we are hiring at Elastic, so make sure you reach out if you are interested.
All right, thank you. Thank you, Nick. And are there any questions? That's the question. Here we go.
Hi, thank you for a nice talk. When you were talking about this wait for service script, I did some research some time ago, and I just feel that there is some pressure on the Docker guys to actually provide some feature that would let you do something like this in a more a nicer way, I would say. I'm just wondering if there are any changes in this area, or if you do any research as well, because my research is like half a year ago, and I was just disappointed by just having some hacked script. And our guys in our /pool project, they just use a stupid delay. They just wait for the databases to come up, because they know by the time that they're probably ready. But it's not nice, so. Yeah,
so Docker has a health check feature now, which you can specify in your Dockerfile. And as a result of that health check, when you do a Docker PS, you will get a notice of starting, healthy, or unhealthy, depending on the status of that particular container. That being said, that works really nice in like, say, swarm mode, when you want to make sure that a container is healthy before doing something. And to be honest, I didn't actually look into doing that in this particular case with changing the way that script works. I should actually look into that. The reason I have a custom Elasticsearch image is that I've actually been experimenting with that health check flag it myself, and it reports back, when I do a Docker PS and I'm developing on Elasticsearch, I can do things when it's healthy, but Elasticsearch can also go into yellow mode, which is kind of like a warning, but not bad, and that's not necessarily something that will keep the test from running. So I'm still trying to figure out a better way of handling that myself. But hopefully, you should be able to target only healthy containers to do something. But still, the bash script, I think, at least with Docker Compose, the bash script will still have to be there. If you're going to do like a Docker stack deploy or deploy service, the Docker services takes a lot more into account that health status check than Docker Compose does.
Hi.
Oh.
I use Docs a lot, and I like it. Thanks for the talk. That's a fine approach. I like it as well.
Mm-hmm.
But what I'm concerned about, I'm using Fedora on my machine, and we run our tests in Travis CI on Ubuntu.
Mm-hmm.
Another developer might run on Mac or Alpine.
Mm-hmm.
And we are all running our own Pythons with the talks or the Ubuntu Pythons on Travis. If you stick with Alpine-based Docker images, isn't that kind of only testing on Alpine and could be broken anywhere else?
Yeah, that's a possibility, and you could definitely expand your matrix to include different base operating systems. But the root core of this is actually going to be, which I kind of I conveniently ignored. Docker actually uses the kernel of the host operating system. So if your tests are running on Docker for Mac or Docker for Windows or Docker installed on Fedora or Docker installed on Ubuntu, the real meat of the issue is going to be how does that kernel behave differently depending on what kernel modules have been installed on how Python runs and that kind of stuff. So you can get really into the weeds on configuring all of this, but the goal here was more about how can I speed up the execution time of a test matrix that starts to get really big. And waiting for talks to run in serial on every different environment can be time consuming. So this is just kind of a strategy that I've been kicking around, and I'm like trying to see if it's a good fit for a way to speed up that Python execution while conveniently ignoring the differences in kernels and the lower level C functions that rely on different kernel modules and stuff like that.
Thank you. Here's a question.
So did you look at talks at all in terms of parallelizing the options? Because that's one of the things you were trying to target. I know also you were looking at trying to smooth over OS level differences, but did you look at parallelizing talks? And if you did, what kind of challenges did you see there that made you move to Docker?
No, I didn't look at parallelizing talks. I did a quick little search before writing this to see if it was possible. The problem I'm seeing with trying to parallelize talks itself is we get into that GIL issue. We could create multiple threads or multiple processes and try to run talks that way. But then you still get into the issue of the GIL and then also creating a utility to actually collect all of the output from that in a sane way so that you know what's actually passed and you're not confused on your output.
Okay, thanks. Any more issues? I do. Oh, here's one again.
Do you have a workshop about this tomorrow? Am I right?
It's going to be kind of close to this, but basically the idea behind the workshop is I know most people, when they're doing their development, they use SQLite as kind of a real easy way to run the tests, to do their development against, and I'm going to try and help you figure out a way to use Docker in a development environment using a production-like backend with your code running in a production-like environment so that you're not having this works on my machine type of scenario. Personally, in the past, I've been bit by MySQL differences. MySQL running on my computer versus MySQL running on the server, and a Django migration that didn't go as smoothly as I anticipated because I had version differences. So I know it's a kind of a niche detail, but I've been bit by it, so I know other people have been or might be in the future.
Thank you. Any more questions? I think we're all out of questions, so thank you, Nick.
Thank you, guys.